Hello dear friends, how are you? This is the last item about STP topics, and this is the another lab for Dynamic EtherChannel and load distribution. Let's go to start. Cisco switches offers two dynamic configuration protocols or two dynamic configuration options, allowing for negotiation using a dynamic protocol to determine whether a link becomes part of an Ether channel. If you remember, we discussed about EtherChannel and we did perform the static configuration for EtherChannel installation between two switches. Dynamic configuration involves enabling a protocol for a specific channel number or channel group number, allowing switches to exchange message and validate configuration settings with neighboring switches. If a physical meets configuration requirements, it's added to the Ether channel. Otherwise, it remains in a down state until inconsistencies are resolved. Most Cisco catalyst switches support both Cisco proprietary Port Aggregation Protocol called PAgP and the another one, IEEE standard Link Aggregation Control Protocol called LACP. Based on the standard 802.3 AD. Well, PAgP is Cisco defined and LACP is IEEE defined. Both protocols can be installed as Ether channel between two switches. While there are differences between PAgP and LACP, they serve the same purpose, negotiating to include only complaint link in an Ether channel. Notably, LACP supports up to 16 links in a channel, with only 8 active at a time. The remaining links act as backups in case of failure in active links, but PAgP just support and will perform 8 active or maximum 8 links in a channel. The speed, correct channel group commands, various configuration settings may prevent the switch from utilizing a physical port within an Ether channel even when manually configured. Before incorporating a physical port into an Ether channel, the switch evaluates its configuration against existing channel ports, requiring identical settings for inclusion. If a new physical interface settings differ from existing ports, it remains configured within the port channel but remains inactive, awaiting resolution of configuration mismatches. The switch conducts a truth check of multiple parameters, including speed, duplex, operational states such as access or trunk, VLAN configuration, access trunk, native, and STP settings. Additionally, switches cross-verify settings with neighboring switches utilizing protocol PAgP, LACP, or CDP for consistency checks. And another item is during neighbor verification, all settings must align except for STP configurations. Keep in mind to ensure seamless integration within the Ether channel. So if you want to use PAgP for configuration in both sides on this, for example, SW1 and SW2, in first side you can perform command channel group 1 mode on, and the another side you can channel group 1 mode on. When you configure channel group mode on, it is not configured in PAgP and LACP. It is not work in PAgP and LACP. It is just work on channel group mode on, and just will perform correctly if another side is configured as mode on. But if you want to configure dynamical Ether channel by PAgP, you can use one side, you can use configure channel group 1 mode desirable, and the another side must be between desirable and auto, one of them. For example, channel group 1 mode on desirable, channel group 1 mode on desirable, or channel group 1 mode desirable or 1 mode auto. And if you want configure with LACP, you should configure the first side as channel group 1 mode active, and the another side and the another switch channel group 1 mode active or passive. When you want the other, when you configure the other item active, all items and all ports will be placed in active mode, or when you configure another side as passive, it will be placed in passive mode, and if active item or ports happens to down, the passive will be changed to active and entering to the Ether channel configuration. The other item I will describe is Ether channel load distribution. Layer 2 Ether channels associate MAC addresses with port channel interfaces rather than underlying physical ports, requiring switches to make forwarding decisions based on specific physical ports. Well, Ether channel load distribution, also known as load balancing, determines the forwarding path for each frame based on numeric values in layer 2, 3, and 4 headers. The load distribution method is configurable using the port channel load balance method global configuration command, which matches fields identified by the configuration method. And another item is different load distribution methods produced varied results, focusing on ensuring message within an application flow use the same link in the channel to prevent message reordering. Load distribution algorithms aim to integrate seamlessly into hardware forwarding ASIC for efficient operation and utilize all active links in the Ether channel, adjusting to change in link availability over time, and while balancing traffic across active links in a goal, the algorithm prioritize message integrity and efficient forwarding rather than sending an equal number of bits over each link. Well, this is the table for configuring keywords for configure load distribution on Ether channel. For example, you can configure source MAC, src-MAC. I will show all of these items in lab after finishing my descriptions. Don't worry about the configuration and practice that. For example, you can configure based on source MAC, based on source MAC address for load distribution packets, and it is in layer 2. Based on destination MAC, source MAC and destination MAC, these three items are will work in layer 2. In layer 3, so based on source IP, destination IP, source destination IP, and layer 2 based on source port, destination port, and source and destination port in layer 2 working. Well, layer 4, sorry, working. And what about the working of Ether channel load distribution? Let me describe one example about the load distribution. For example, when utilizing the load distribution method for source MAC, src-MAC, which considered the MAC address, the source MAC address, frames sharing the same MAC address, are directed over a single link. The concept is demonstrated in this PowerPoint slide using hypothetical MAC addresses where frame with source MAC address 1 are routed over link 1, source MAC address 2 over link 2, source MAC address 3 over link 3, and so on. Well, but what about the load distribution? Cisco offers a range of load distribution options to enable engineers to analyze network flows and identify fields with diverse values such as source and destination MAC addresses, IP addresses, or transport layer port numbers. Increased variety in the values of these fields enhances balancing effects and reduces the likelihood of uneven traffic distribution across links. By examining the diversity of values in network traffic fields, engineers can optimize load distribution for improved network performance and resilience. Well, Now it's time to configure and practice. Now let me configure, and we need two switches to models 2960, and I will put the download link for this lab manuals for you. I want to configure two labs, one for LACP and another for PAgP. First, LACP to configure two ports, and I want to configure, for example, gigabit Ethernet 01 and 02 connected together, and configure as the Ether channel. Before connect physical ports together to each other, it's need to configure commands to prevent making loop on switches. On switch 1, on SW1, for example, SW1, and the second is SW2. On SW1, how I can configure dynamically Ether channel by LACP commands. Okay, go to config, enable, configure terminal, interface range, gigabit Ethernet 0/1 space dash space 2, select two ports at the same time, channel dash group, one mode active, well, exit, and now it's time to go to interface, port channel 1, switch port mode trunk, to make that virtual created port channel as the trunk port. And now it's time to configure channel group on SW2. SW2, enable, configure terminal, interface range, gigabit Ethernet 0/1 to 2, channel group, one mode active, exit, interface port channel 1, switch port mode trunk. After configuration, now it's time to connect two switches from one to the another, gigabit 0/1 to 0/1 and 0/2 to 0/2, and wait to that configuration change to up state. Look at here, interfaces changed to up, and for verify, show Ether channel summary is good command. Show Ether channel summary, and verify that the Ether channel is in the up state and has the correct number of ports bundled in the channel. Port gigabit 0/1, 0/2, and P means in port channel, and state is in use, up and in use. And let me check show interfaces status. PO1, port channel 1, as you can see, port channel 1 is connected and is in trunk mode. Now let me add two PCs for testing connection between two computers, and connect one PC from the fast Ethernet to one of the switch access ports, and this one, and setting its IP address, for example 10.0.0.1.0.0.1, and the another 10.0.0.2, 10.0.0.2, and finally check by ping command. This is in up state, wait, it's up also, and ping 10.0.0.2, and we can see all packets, ICMP packets successfully transfers from the one switch to the another and to the destination computer. So that was the configuration sample for LACP. Now let's go to configure PAgP lab and perform that and practice that. Okay, again add two switches and two PCs, PC1, PC2, SW1 and SW2, and let me start the configuration. On SW1 interface range gigabit Ethernet 0/1 to 2, and for configuring PAgP I can use, for example, desirable mode. Channel group group 1 mode desirable exit interface port channel 1 switchboard mode trunk and the another side also desirable configuration enable configure terminal conf terminal interface range gigabit 0/1 to 2 channel dash group 1 mode desirable exit interface port channel 1 switch or mode trunk. That's all. And now it's time to connect computers and switches together. For example, fast to fast from this PC to fast Ethernet of the switch, and connect gigabit Ethernet 0/1 to 0/1 and 0/2 to 0/2, and finally setting the IP address configuration, for example 20.0.0.1 and 20.0.0.2, and wait the switches coming up. Okay, ping from 20.0.0.1 to 20.0.0.2, ping 20.0.0.2. The ping is okay, and show EtherChannel summary will show us the configuration status about the port channel 1, and the ports are resides in this port channel. The protocol is PAgP. That's all. Regarding load balance configuration in EtherChannel, considering that the packet tracers simulator does not support this, I will say in theoretically, and I will put it in the PDF file of the lab so that you can learn and use it wherever necessary. For configuring load balancing in EtherChannel, you should enter to global configuration mode of the switch, and by command port channel 1, the port channel number, and load balance, load dash balance, then the load balance meter, for example, SRC dash MAC means source MAC, or SRC or source destination MAC, SRC dash DST MAC, or any other item maybe you want based on your need. This is configuration for load balancing in EtherChannel, and for testing that you should use command in enable or in exec mode or enable mode. You should use test EtherChannel load balance command. Such as this, for example, imagine you have two switches that connected to each other, and you configure EtherChannel by this command: enable configure interface range gigabit Ethernet 0/1-2 channel dash group 1 mode desirable. Well, channel group 1 mode desirable, channel dash group 1 mode desirable. Yes, port channel created, exit, interface port channel 1, switchboard mode trunk. These commands was for creating EtherChannel as dynamically, and you can configure by this command in global config port channel 1 load balance. This command is not supported in Cisco Packet Tracer, but the command, as I said for you, is this: port channel 1 load balance. For example, like this, you can use source destination MAC. This is not supported because this is the simulator, but in real switch it is not any problem, and you want configure that. And you can also test it by test EtherChannel load balance in enable mode. Test also not supported in Cisco Packet Tracer. Well, dear friends, with this video, the discussion of switching in the CCNA course is almost over, and we will gradually enter the more interesting discussion of routing, of course, other topics such as wireless networks and Cisco security topics, and so on. Have a nice time. Wait for my next video about new topics. Bye.